Hello class, welcome to week 5. We've covered a lot of information in this course, and you will use all of it to complete your final individual assignment. So I put together this lecture to review key points that you need to complete your assignment this week. The best place to start is with an understanding of terms. Information assurance and information security are a little different. Assurance is stakeholder and customer confidence that there is the right balance between risks and controls. It's implementing controls that are reasonable and appropriate given the amount of risk. For example, failure to implement the right control or any control enough to mitigate risk to an acceptable level to all stakeholders and customers is not assurance. Also, if customers don't believe the organization is doing the right things to manage risk, their perspective of assurance is low. In both cases, revenue is threatened. Information security ensures the confidentiality, integrity, and availability of information resources. It consists of the controls and procedures we implement to achieve assurance, strategically and operationally. Today, information is a valuable asset. It consists of collections of data that form intellectual property, customer relationships, production procedures, supply chain management, and many other assets critical to business operation. The infrastructure that processes, stores, and delivers these assets is also part of the asset it supports, especially as it relates to ensuring availability. We classify these data sets so we can better understand value when performing business impact analysis during risk assessments. It helps determine the resources necessary to protect each asset. This includes eliminating single points of failure that elevate the risk of long-term system failure to an acceptable level. Assets can change over time, so it's necessary to periodically review the value of each asset to ensure risk is properly managed. Security management is risk management. I can't say this enough. Too many security professionals implement controls because they assume they're needed. This kind of need is built by vendors and other security professionals who forget the risk element when blogging about the necessity of implementing the most current security technology. Management can decide to do one of 4 things when risk is identified in a risk assessment: accept, transfer, mitigate, or avoid. We accept risk when it's considered lower than the benefit we receive. Another way to assess this is to look at controls cost. Will the annual cost of one or more mitigating controls exceed the annual business impact? We transfer risk with insurance in cases where risk is too high, but controls are as good as is reasonable and appropriate for business operation, and the cost of the insurance is lower than the potential business impact. We mitigate risk with controls when the annual cost of the controls is lower than the potential annual business impact of the risk. Finally, we can avoid risk by simply removing or not implementing that which is causing the risk. The formulaic model for risk is usually written as risk equals threats times vulnerabilities. While this provides a way to quickly see the relationship between these elements, it has little value when trying to calculate risk during an assessment. We use one of 3 methods when calculating risk: qualitative, quantitative, and hybrid. Qualitative assessments use the experience of the assessment team to determine business impact. Values, usually between 1 and 5, are assigned to things like the annualized likelihood of occurrence and business impact. In a quantitative assessment, we use real dollars estimated by working with management. In most cases, businesses do not have these numbers, nor do they have the time to calculate all of them. Consequently, we typically conduct a qualitative or a hybrid assessment. A hybrid assessment uses actual dollars where they exist, but relies largely on qualitative numbers. Hybrid assessments are very common and provide the information managers need to make informed risk decisions. Approaches to risk assessments can differ between organizations, but they generally follow the same steps. The first is to complete an inventory of assets. Unless you know what you have, you can't determine the risk to each system or to the network overall. Many organizations have devices connected to their networks that are long forgotten. These unpatched, unmonitored desktops, servers, and other devices provide great points of entry to attackers. Once you complete the inventory, you classify each dataset and the system and network infrastructure that stores, processes, or moves that dataset. At this point, we're ready to begin identifying probable threats. We identify probable threats by conducting research about incidents affecting other organizations in our industry and within our geographic area. These incidents include cybercrime, terrorism, and natural disasters. We can also visit websites that provide lists of common threats and select those that are likely to affect our organization. Once we understand the threats we face, we assess the vulnerabilities associated with these threats. Let's take a customer database as an example target. If a threat is an attacker breaching our customer database, we step through the path the attacker would take. We assess the configuration and status of each device along the path and identify vulnerabilities. We also look at existing detection and response controls to determine if we can quickly detect and contain an attacker. In parallel with the attack path assessment, someone is also performing a business impact analysis. This analysis considers the financial and other costs associated with lost data or unavailable systems relevant to the customer database. We use this information as the business impact portion of our assessment. At this point, we have information about the attacker, our vulnerabilities, and the potential cost if the attacker is successful. We use the likelihood that an attacker will be successful and the potential cost to calculate either qualitatively or quantitatively the risk. Risk is ultimately the annual expected cost of an attack. If we understand the risk, we make recommendations to management whether to accept, transfer, mitigate, or avoid the risk. The risk assessment we just stepped through is not a day-to-day process. Rather, it is performed when a system is modified, first implemented, or annually, whichever occurs first. This graphic shows operational risk management, something we do every day. We continuously monitor for unusual device or network behavior. We assess this potentially unwanted activity and respond if it proves to be malicious. This process feeds the overall risk management framework, resulting in possible changes to risk levels immediately or during the next system risk assessment. This is a list of threat examples. I won't read them to you, and they are self-explanatory. A complete list is found in your text. Let's step through 3 detailed risk examples. Keep in mind that this is the approach you would take to explain a risk to management. Business managers don't usually care about or understand the underlying technology. In our first example, an insider steals intellectual property and provides it to a competitor. This results in loss of competitive advantage. A worm makes its way into the network, causing a denial of service situation. Business operation is interrupted. An attacker breaches a customer database and steals payment card information. This results in loss of short-term and long-term revenue. Costs incurred due to managing the breach and customer perception are also possible. The business impacts of loss of competitive advantage, business operation interrupted, etc., will be based upon the business impact analysis performed during the risk assessment. And those are the numbers that you would give to management to show the impact on the bottom line if one of these risks actually happens. Finally, an increasing challenge for security management is use of social networking. Most attackers today target users. They use phishing lures to attract mouse clicks. This results in users clicking malicious advertising and other links present on social networks. Once this happens, malware is installed on a user device used either to collect sensitive data on the device or as a jump-off point to attack other locations on the network. Also, attackers scrape social networks for personal information related to employees at target organizations. Information about user likes and dislikes, job positions, and other bits of personal data about users make it much easier for attackers to create lures, both on websites and in email. Finally, users inadvertently share sensitive company information from time to time. The best defense is preventing users from installing anything on their computers via group policy objects or other controls. No user should have local admin rights for day-to-day operations. Also, email and web filtering are critical controls for preventing lures from reaching users. Finally, users must be trained about the dangers of liberal use of social networks. This slide shows a list of regulatory and standards organizations most often encountered. In addition, security teams must understand local and state laws covering such areas as privacy and breach notifications. And remember, PCI DSS is not a law or regulation. It is a payment card industry standard enforced by the payment card industry. Security policies form the foundation of an organization's security framework. They provide management guidance on how to comply with regulatory and industry standards. Policies also provide statements about management's expected outcomes as related to protecting information resources. We apply policies at 3 levels: enterprise, system, and issue. Enterprise-level policies, also known as program policies, address security across all issues and systems. An enterprise security policy sets the strategic direction, scope, and tone for all of an organization's security efforts. It assigns responsibilities for the various areas of information security, including maintenance of policies and the practices and responsibilities of end users. It also guides the development, implementation, and management requirements of the security program. Issue-specific policies are designed to control use of a particular resource, asset, or activity and are provided to support the organization's goals and objectives. An email policy is an example of an issue-specific policy. While issue-specific policies are formalized as written documents readily identified as policies, system-specific policies sometimes have a different look. They can often function as standards or procedures to be used when configuring or maintaining systems. For example, a systems policy might describe the configuration and operation of a network firewall. This document could include a statement of managerial intent, guidance to network engineers on the selection, configuration, and operation of firewalls, and an access control list that defines levels of access for each authorized user. Policies are supported by standards, guidelines, and procedures. Standards and guidelines are derived from policies and are usually included in the relevant policy document. According to the SANS Institute, a standard is typically a collection of system-specific or procedural-specific requirements that must be met by everyone. And a guideline is typically a collection of system-specific or procedural-specific suggestions for best practice. Standards and guidelines provide detailed or recommended general solutions, but they don't provide information about implementation. Procedures are step-by-step instructions for how to perform a business, IT, or security task. Business procedures are written by business managers and ensure policy compliance when employees use them. IT and security procedures are written by the relevant managers and ensure IT and security perform their task as needed for security compliance. The look of a security policy can vary between organizations and between the levels of enterprise, issue, and system. However, this slide provides general content we usually see in all policies. We start with the title of the policy. The title should clearly state what the policy covers. For example, Internet Usage Policy or File Server Build Policy. This makes it easy for users to locate the correct policy. Next, we clearly state the purpose of the policy. This is typically the policy statement that includes management's expectations of outcomes. The authorizing individual and author information are important. The name of the authorizing person provides users with a point of contact for requesting policy review or change. The author name is used by employees to obtain clarification on policy wording and processes. Reference to other policies lists the policies related to the purpose of this policy. For example, an email policy might refer to a data classification policy when addressing the kinds of information that can be sent via unencrypted email. Scope defines the users, facilities, data, and infrastructure controlled by the policy. During many projects, exceptions to policy might be needed. Every policy should describe how to apply for an exception. The exception application is usually submitted to the authorizing individual. Policies compliance must be monitored and enforced. Compliance management and measurements provides the name or individuals or teams responsible for these tasks. It also includes sanctions for individuals who do not comply with the policies. Each policy has an effective date. Sometimes an expiration date is also provided. In any case, a table with changes to the policy is included with the policy document. At the very least, each policy should be reviewed each year and necessary modifications made as business processes and threats change. The table of changes provides a history of what was changed, who made the change, and who authorized the change. Finally, key terms in the policy are defined. Everyone should clearly understand what the policy addresses. The System Development Lifecycle, or SDLC, follows a system from inception to disposal. Integrating security activities into the SDLC is necessary to ensure cost-effective and continuous safe system operation. In the initiation phase, we perform the preliminary risk assessment. We look at the data involved, how the data will be used, and the potential threats. Using this information, we create the security requirements for the system. During the development or acquisition phase, we perform a full risk assessment, adjusting security requirements as necessary. In addition, the development team performs unit testing and peer reviews to ensure safe coding standards are followed. The implementation phase includes quality assurance testing and user acceptance testing. All test plans should include testing of security requirements, including those involving least privilege and separation of duties. The operations and maintenance phase is the longest. It is the actual period during which the system is used to support business operations. During this phase, monitoring in the form of log management or threat analytics is performed continuously. Risk assessments and vulnerability scans are done when changes are made to the system or annually, whichever comes first. They are often part of the change management process. No change is made to the system unless it passes through a formal change management process. This includes most or all of the steps included in the initiation, development acquisition, and implementation phases. Finally, the disposal phase comes when the system is no longer needed and is replaced or eliminated. This requires wiping all data from all unneeded storage media and archival of information required by law or policy to be kept for a specified period. Use of the cloud is not something most organizations can resist. It usually is less expensive and often more secure than keeping the information resources in a local data center. However, there is often resistance because IT fears losing control or because of usually unwarranted security concerns. In reality, we control the security of resources hosted by a cloud service provider or CSP. We do this by first selecting a reputable CSP with third-party assurance of adequate security practices. This is usually done by asking for and reviewing recognized certifications, such as the SSAE 16. The CSP's third-party assessment must be up to date, and continued updates must be part of any agreement into which you enter. Include your own security expectations into your written agreement with the CSP. This might include including CSP compliance with one or more of your security policies or a HIPAA business associate agreement. In many cases, you might not want to rely completely on third-party assessments. In these cases, include in the agreement the CSP's approval to allow you to conduct your own risk assessments or audits. The biggest challenge today is management of Internet-connected systems. Before the Internet, information security was simply user ID and password management. There was little risk that someone from the outside, for example, could access internal systems. The Internet changed all that. In this class, we classify any device communicating via TCP/IP over the Internet as Internet connected. Internet connectivity immediately elevates risk. Servers should never communicate over the Internet unless the connection is explicitly approved. All other connections should be blocked by firewalls or other network management devices. Further, browsers on servers should be disabled or deleted. No critical system should have direct access to the Internet. Healthcare delivery systems, for example, should never have Internet access. We often allow vendors access via the Internet so they can maintain business or facility management systems. This access should be tightly controlled. Access to facility management systems, such as environmental controls or similar systems, should be separated from the business network. This is commonly done with virtual area networks, VLANs, and VLAN access control lists. And then there's the Internet of Things. Coffee makers, televisions, industrial controls, and other devices that can easily connect to both your network and the Internet. Make sure you understand the risks and segregate these devices onto network segments separate from those used for normal business operation. Encryption converts plain text to meaningless text, as shown in this slide. While this is a good idea when an additional layer of access control is needed, it is not a silver bullet. In addition, it is not a good idea to use it everywhere for everything. We always encrypt sensitive data sent over the Internet, usually with TLS sessions. Mobile storage containing sensitive information should also be encrypted. Databases and file server data should be encrypted if a risk assessment shows that an additional layer of security is needed to reduce risk to an acceptable level. And we encrypt whenever required to do so. Encryption can be expensive and difficult to manage. This is why we only use encryption when it is reasonable and appropriate. We have several common methods for securing information assets. First is access control. Access control is the method of verifying the identity of a person, service, or application, which is called authentication, determining the level of access the verified identity is allowed, and this is called authorization, and logging all activity between the identity and the information resource, which is accountability. If an attacker gets physical access to a device, game over. So ensuring good physical security is an important part of protecting the CIA of information assets. The purpose of physical security is to delay the advance of an attacker until detection and response is possible. This includes several layers, including fences, locks, and alarms. Network segmentation helps prevent malware and attackers from easily moving across the network. This is especially true if we use VLANs to create security zones. A security zone is protected by access control lists that control the traffic that can enter the VLAN. In addition, we might add a firewall and IPS to the VLAN in addition to the security devices at the perimeter of the network. Further, VLAN should separate critical and sensitive systems and data from public or vendor network segments. Risk assessments are used to continually check to ensure new threats and vulnerabilities have not elevated risk higher than expected. They are a primary means of ensuring security initially and over time. Finally, log management and threat analytics help us detect threats active on our network. The faster we can respond, the lower the business impact related to a security incident. In addition to risk assessments, audits are another tool we use to measure security success. Audits check for policies necessary for achieving compliance with regulations, industry standards, and management's expectations. They also check to ensure business continuity and disaster recovery documentation exists and is tested. Auditing checks for compliant outcomes. Examples include the proper management of terminated employee access, the expected separation of duties, and least privilege requirements. The bottom line, audits check to ensure that the outcomes specified in policies are actually achieved. The largest vulnerability within any organization is its workforce. This is one of the reasons we write policies and develop procedures to help users do the right things. However, users cannot be expected to comply with policies and follow procedures they don't know exist or don't understand. Employee training and awareness activities make employees aware of security threats, challenges, policies, and procedures. This begins with new hire training and continues with annual refresher sessions. Awareness activities, including newsletters, posters, and login messages, help reinforce the right behavior between training sessions. Business continuity planning helps us keep systems running so we can process and deliver information when and where needed. We start planning by identifying all critical business processes and the infrastructure and software that supports them. For each process, we look at our ability to recover from failure of a system component, recovery from a catastrophic event, or anything else that might cause an interruption. Business continuity planning requires a documented plan and a trained recovery team. Recovery teams often test plans quarterly, making changes to the plans as necessary. Business continuity plan adjustments must also be part of the change management process. In this final slide, we look at one of the most important controls and one that is often ignored. The quality of our incident response capability determines the business impact the organization experiences when the inevitable security incident occurs. The response process includes 6 steps. First is detection. As we discussed in other slides, monitoring for and identifying threats active on our network is an important part of the operations and maintenance phase of the SDLC. If we can't detect a security incident, we can't respond. Once we detect an incident, we analyze it to determine what is happening. This step allows us to adjust our response to be more effective. Following analysis, we contain the threat. If a worm is present on a VLAN, for example, we shut down all traffic to and from that VLAN. The eradication step includes wiping malware from systems and removing means of entry for attackers. Business process recovery restores business processes interrupted by containment and eradication efforts. Finally, we perform a root cause analysis to determine what happened, why it happened, and how we can prevent it in the future. We also examine our response to see if we can improve it in some way. To implement a response plan, 4 foundational tools are needed. First, we need a way to detect events. Second, we need a documented response plan, including notification lists and decision trees, quickly leading first responders through the initial response steps. The documentation should also include how we track response activities and responsibilities. The response team must be trained and familiar with the response process. One of the worst things that can happen when a security event is detected is first responders standing around, not knowing what to do next. Finally, the response team should be able to rely on a documented business continuity plan and recovery team to help with the business process recovery. Well, that's it for the lecture. If you have questions, please join in the discussion in the discussion area that I've designated in the classroom for going through concepts related to this final assignment. This will help everybody make sure that they've gotten all the key concepts right that they've been introduced to in this class, and that they can properly put those into a presentation for the capstone assignment for this class. Good luck and have a good week.